Hello folks, in this video we will go through dash redirection. This is the node I made based on tutorials found in Google. Let's start with the first one. We know that the following command writes the output of ls command to the dir tree list file. We're talking about this command over here. So we know that it takes the output of the ls command and save it to this file. But how does it work under the hood? First thing you should realize is that the redirection is set up before the ls command is executed. So before we run this command, the ls command, we set up the redirection. In our case, the redirection is the right hand side. So let's investigate what the redirection in this case does. At the beginning, we typically start with 3 file descriptors. File descriptor 0, 1, and 2. File descriptor 0 is standard input. File descriptor 1 is standard out. And file descriptor 2 is standard error. What are they? Standard in is the input from keyboard. Standard out is output sent to the terminal. And standard error is the erroneous output to the terminal, like when you execute a wrong command. As I said, we start with these 3 file descriptors, each pointing to the current terminal, which is something like this. So we have the 3 file descriptors to start with, all of them pointing to the same terminal. Now the redirection. Redirection here changes file descriptor 1 to point to the file. You can see here. Second row over here. So the standard out now points to the directory tree list file. So that's the change. Now that the redirection has been set up, it's now time to execute the command, the ls command. This will generate content of the current directory, including the subdirectories, in long listing format. That's what the ls with the flags L and R does in this case. This output goes to the standard out, which is the file descriptor 1. And have a look. File descriptor 1 now points to the directory tree list file. So the output is saved to that file instead of the standard out. Instead of the terminal, it now redirects to the file. That's why command saves its output to this file. Note that the redirection here only applies to the current command. Any subsequent command will start with a fresh plate as before, which is over here. So what I'm saying is, the redirection here only applies to this line. Here are other combinations. This is what we seen here. It's same as what we've seen. So this redirects standard out to point to the file name. This is just appending. What it means is if you do this, whatever that is inside the file name will get truncated to 0 length, so it will empty the file. If you don't want this redirection to truncate the file, you do double greater sign, which is this one. Do it twice. Okay, so similarly, this one points the standard error to this file, but this command also truncates the file name to 0 length. And if you don't want to do that, you do the same. You do double the greater than sign. Okay. And if you want to point both standard out and standard error to file name, you do this. Let's say here, this is the same as these two over here, which makes sense, right? Next part. The redirection over here points the file descriptor 1 to the file name. So this is change that has been applied. Note that this will truncate file name to 0 length, same as what we've seen it before. If you don't want to wipe the content of file name, then do just the double greater than sign over here. Also note the effect of this exec redirection will be inherited by subsequent commands. So that's different from what we've seen over here, which only applies to this line. This is useful when you want to redirect all subsequent command output to file name. What we're doing here is to copy the pointer that is residing in file descriptor 1, which is the standard out, and copy that pointer to a new file descriptor. So after this, we both end up with well, let me go through this. The file. So what we've done here is we start with these 3 file descriptors, and all of them point to the current terminal, right? And then we're copying the pointer that is in standard out to a new file descriptor, in this case file descriptor 6. So what we happen, it points to the terminal as well. Okay. So what is the default behavior of the standard out? It directs the output to the terminal, right? That's the default behavior. So if you copy that pointer to a new file descriptor, in this case file descriptor 6, it has an effect of saving the default standard out so that you can reset it later. Okay, so the second line, now it changes the default standard out to point to the out file instead. You say here point standard out to out file. So what happened? It changed standard out to point to the out file. Okay. So whatever you echo to the terminal subsequent in the subsequent commands, it'll all be directed into this out file. It will save it to the out file. So you say here, you echo the string jumping kangaroo. What happens is the default behavior is of an echo command. It will direct its output to the standard out. But look here, standard out now points to out file. So whatever you echo here will be saved to the out file. So if you cat the out file, it contains the string that you have just echoed, right? But what this does is restores output. Why? Because it's copying the pointer in descriptor 6 to the out standard out. If you have a look here, pointer inside descriptor file descriptor 6 points to the terminal, which is the default behavior of the standard out. So if you copy that pointer back to the standard out, now the standard out no longer points to the file but to the terminal. So if you do echo high here, just echoes to the terminal. So that's back to the default behavior. Okay, I'll show you. Okay. Okay, so firstly, we copy the standard out to file descriptor 6, so you can restore the standard out to its default behavior later, which is to output to the terminal, right? So you're copying that original pointer to a new file descriptor, in this case file descriptor 6, and then this redirection now point the standard out to the file name called out file. Now anything that you type, any command that you type subsequently, its output will be saved to the out file. So if you echo jumping kangaroo string will be saved to the out file. Okay, now we want to restore standard out, so we are copying back what was in descriptor 6 back to the standard out, which you might remember is pointing to the terminal. So this command will restore standard out to point back to the terminal instead of out file. Okay, so if you look at the content of out file, you can see jumping kangaroo. And now if you echo high, can you guess what will happen? Yes, it will output to the terminal again because of over here. You're copying back the terminal, pointer to the terminal, which is stored in descriptor 6 as we have saved here, back to the standard out, so that standard out no longer points to alpha but back to the terminal again. Okay. Next section. So this is what we just been through. This redirection copies the pointer in file descriptor n to file descriptor m. Okay, so what we've done here, for example, the first line, what it does, it copies the pointer in the standard out to this new descriptor 6. If you think about it, what's in standard out to begin with? It points to the terminal. So copying that pointer to file descriptor 6 so that file descriptor 6 now has been opened and it points to the terminal. Okay. So for example, this redirection here copies the pointer in the standard out to standard error, so they point to the same file. We start from scratch, we don't get much difference because here we copied the pointer to the terminal from standard out to standard error, and nothing has changed because standard out and standard error points to the same terminal to begin with. Okay, but if we change what standard out points to beforehand, then things are different. Okay, so consider the command with redirection over here. Remember, we don't execute the command first. We set up the redirection first and then execute the command afterwards. Okay, so here, the first redirection, we go from left to right. First redirection, as we've seen before, sets the standard out to point to our file. So that's what happens after the first redirection. Then we copy the pointer in the standard out to standard error, so we end up with this and this. So both standard out and standard error now point to the same out file. Say here, we both standard out and standard error point to out file. Okay, but if you do this time, if you do this redirection before this one, it has a totally different effect. Okay, so we've seen here, over here, because we start with standard out and standard error pointing to the same terminal to begin with, this redirection has no effect. And then we change the pointer in standard out to point to this out file, so only the standard out has been changed. Okay, so they're totally different. The order makes a big difference. To the next section. Okay. First, note that each side of the pipe, which is this one, run in their own subshell. So redirection in either side don't affect the other. Also, as usual, redirections are set up before any command just run. Okay, so if you had redirection over here and another one on the right hand side, say, they don't affect each other, they run in their own subshell. Okay, this is a special case and used quite often, so let's delve in. We start with just the simple pipe and omit this redirection for now. So we just pay attention to this. This is a special case because this is a pipe, so that on the left hand side, the standard out is pointing to the pipe. On the right hand side, standard in is pointing to the pipe. That's what we start with. Okay, this is the default setup of a pipe. On the left hand side, you can see standard out points to the pipe, and on the right hand side, standard in points to the pipe. Now let's perform this redirection. We're copying the pointer to the pipe from standard out to standard error. So what's here? The source is the standard out on the left hand side of the pipe, which is pointing to the pipe. We copy that pointer to standard error, so we end up with this. Both standard out and standard error are now pointing to the same pipe. Okay, and of course the right hand side doesn't change. Standard in is the pipe. Okay, so you can now see that both standard out and standard error from command 1 are piped to the same command 2. We can do the same by doing this. The special syntax over here is the same as doing this. So if you run this command, it will have the same effect. It will pipe the output from the standard out and standard error to the same pipe on the right hand side. Okay, so this is just a shorthand because this is a special case. Okay, now let's move on. This is just a peculiarity which might hang you in suspense because it's not obviously it's not initially obvious. Okay, so this command is an erroneous command. There's no XYZ flag for the ls command. Okay, so you see here. Okay, so let me oops. Okay. So let's fill this in. On the left hand side, the standard out points to the pipe on the right hand side, and on the right hand side, standard in points back to the pipe on the left hand side. Okay, so you can see that standard error is not piped to the grep command on the right hand side. As you can see here, standard error, which is file descriptor 2, points to the terminal. Only the standard out points to the pipe. Okay, so if you run this pipe command, it will output the error to the terminal because, as you can see, standard error is pointing to the terminal, and this command over here on the ls xyz it's an error. Okay, so it's outputted to terminal by default. But if you do this, so that what happens now, it changes both standard out to standard error to point to the same pipe because of this shorthand over here. Now if you run this command, the error from this erroneous command will be piped to the right hand side because here standard error also points to the same pipe. But if you run this, there will be nothing on the terminal because the error message has been piped to the right hand side, and the grep command on the right hand side doesn't find any match. So there's no output because there's no match, but this means standard error was piped to the grep command. Okay, so I'll show you. As you see, if you do this, it's an error. What's happening here is that, you know, this error message over here, it's not from standard out, it's from standard error. Okay, and if you do here, contrary to your intuition, this error message is not piped to the right hand side, just outputted to the standard error by default because we start with this. Okay, standard error points to the terminal to begin with, so that's why you can see the error message. Okay, if you do this, then standard error also points to the same pipe. So what happens? This error message will be piped to the right hand side, and the grep finds no match from this error message, so you will produce no output. But by this we know that that standard error has been piped to the right hand side. So that's why there's no output, because this error message has no match with the XYZ. Okay. Okay, next section. So this is just using a redirection on a code block like while loop to feed in the content of a file as an input stream line by line to the code block, in this case a while loop. Okay, so what happens here, say the foobar contains 6 lines like this over here. We're feeding in the content of the foobar to the while read command line by line. Okay, so the while read name means you will read line by line and then assign that line in a variable called name, and you do whatever you want with it in each iteration. In this case, it just says my name is and the value of the line. So you can guess that the content of foobar will be Abraham, Lincoln, General Motors, Hyundai, and Genesis. Okay. So just to remind you, while read name means it will read each line from foobar and assign that line to a variable called name. Okay, so here the point is you realize this redirection over here on the right hand side of a code block, in this case a while loop, is a redirection. You'll see later, but using redirection in this way will avoid the issue with the subshelling, a subshell. I'll get to that later. Okay, next section. This syntax just opens the file name for reading and writing. Assign file descriptor to it. We could use this to write at a specified place in a file. Let's start with this example. So we echo the string to out file. We've seen this syntax before. Just write 1, 2, 3, 4, 5, 6, 7, 8, 9 to out file. And then we open out file for reading and writing using this peculiar syntax over here. And then we read 4 characters from the first line. But we know that alpha only contains 1 line, but this command visits the first line and moves the pointer 4 characters to the right. So the pointer is now at here. And then the next command writes the dot in place of the next character. Okay, so 5 becomes the dot. And then we close file descriptor 3 that we opened here. Then if we cat the out file, you can see the 5th character is replaced with the dot. Okay, so let me go through that again. Let's try something different. Okay, so let's do A, B, C, D, E, F, G, H, I, J, K. Okay, and then we save it to out file. And then we open out file for reading and writing. Let's go move the cursor to the 4th character of the first line, and of course alpha only contains one line. And then change the fifth character to maybe 0, and then we close the file descriptor we opened for reading and writing alpha. And if you look at it, you see the fifth character is changed to 0. Okay, so it's the same effect as this one. Okay, now the pipe is used to chain together a series of commands, scripts, files, and programs. Here's an example. So we get the output we get the content of the ALF file and we send it to the standard out. Then we sort it, and then we delete any duplicate lines and save the output to result file. Okay, let me show you what unique command does. Okay, so let's line 1, line 2, line 2, line 2, line 2, line 3. So you can see here lines 2, 3, 4, 5, they are the same. Okay, now if you do unique on here, you see there's only one occurrence of line 2 while we had 4 of them to start with. That's what the unique command does. Okay, and then we save the output to the result file. Okay, next section. This is just an extension of what we've seen over here. This just feeds in the input stream, but if you also do this, it will redirect the output to a output file. Okay, so let's look at here what this does. It will read the content of foobar line by line, and then assign each line to this name variable per iteration of the while loop, and then you do whatever you want with the name. And in this case, you will echo my name is name, and at the end of the while loop, you will save whatever has been sent to the standard out to this names list file. So let me show you. Let me check what's in the alpha. Any useful? Oops. Okay. Get rid of my name. Okay. Then save it back to names list. Oops. What happened? Ooh. Okay. I'll just copy and paste it. Okay. So we got these names, right? Okay, so I'll just do, I don't know, while redirection in out. Okay, just copy it here. Okay, so we are feeding in the names list, and we're gonna save it to out file. Okay. Do you understand what's going on here? We're feeding in the input stream consisting of the lines containing in the names list file, and after the while loop has finished, whatever that was sent to the standard out, all of them get saved to out file. So what you would expect, the same content will be now saved to out file. Okay. It's done. Look at the alpha. See? Well, it says my name is because, oops, because I made a mistake. I didn't change it here, but can you see it changed? It changed from this to this, and all the output was saved to out file. Okay, very good. Okay, and the next section. This is what we saw before, but I think we saw it as an example of a pipe. This command was on the left hand side, I think. Let me have a look. Here, I think this was the same example, but in this case it was a pipe. Okay. Okay. All right. Where are we? Okay, here. This ls command is an erroneous command, so any output is sent to standard error. And you know that by default standard error points to the current terminal. The following command saves the error message to out file. Okay. So you know that the is you first set up the redirection from left to right. You do this first, and then this. After all the redirection has been set up, then you execute the ls command in that order. Okay, so what's going on here? First, the first redirection points the standard out to out file. Then that pointer is copied to standard error. So redirections are set up such that both standard out and standard error point to out file. That's why the error message is saved to out file. Okay, so what's the difference here? We've gone through this before. Here nothing is saved to out file. Why? Firstly, this redirection has no effect because both file descriptors, standard out and standard error, point to the current terminal to begin with. Then this redirection points standard out to out file. But the ls xyz is an erroneous command, so the error message is sent to standard error, which points to the terminal. So if you run this, you will see the error message printed to the terminal. Nothing is passed to standard out because this is an error message. It outputs through standard error, so there's nothing to be sent to out file. So for this reason, the error message is sent to the terminal, but nothing is saved to out file. Okay, so let me go through that again. This is an erroneous command. It prints the error message, and you must not make mistakes thinking that this error message has been fed through standard out. That is not correct. This error message has been printed through not standard out but standard error. File descriptor 1 is standard out, file descriptor 2 is standard error. So in this case, this error message has been printed via file descriptor 2. Okay. So let me just do this. What you expect, it will still print the same error message because standard error points to the terminal to begin with, and then you point the standard out to the out file, but there's nothing to be fed to the out file. So the error message still prints to the terminal, but there's nothing in the out file. Okay. For completeness, let me take you through it line by line again. We start with this. Well, okay, so we start with this, and then if you do this, what happens? It copies the pointer in standard out to standard error, but both start with pointing to the same terminal, so this redirection has no effect whatsoever. You get that? Sorry, and there's no file descriptor 6 in here. Okay, so and then well, this, what happens after this redirection? Can you guess what will happen? Standard out will point to the out file. So you run this lsxyz, and then that means it's an error, so it will print to the terminal. Okay, but nothing is sent to the out file because lsxyz is a wrong command. So the error message will be sent to the terminal, but nothing is sent to out file. Okay. Very good. Next section. This is just closing file descriptors. So well, there's nothing here. Or let me just go through it. This one closes input file descriptor n. You know why it's input file descriptor? Because it has less than sign, okay, instead of greater than sign. Okay, so if you gonna close standard in, the short form is just this: omit the digit, and this closes our file descriptor. Why? Because of this sign over here. It differs from this one, right? This is greater than sign. That signifies it's a output file descriptor, and the minus means the same on both occasions. It means close file descriptor n. Okay, so and you can shorten the closing out standard out by omitting the digit and just do this, similar to closing the standard in. Okay, so those are the shorthand forms. Okay, now talk about closing file descriptors in a pipe. Closing file descriptor inside a pipe will not affect outside of the pipe command. It's just a peculiar point. Here I'm closing it on the left hand side of the pipe and right hand side. They don't affect each other, nor does it affect subsequent commands. Okay, so closing file descriptor 3 here won't close it for the terminal, but if you follow up with this exec, now we are closing file descriptor 3 for the terminal. Okay, now the interesting bit. Okay, exec can be used to apply terminal-wide redirection. Okay, so what we've seen here, this, so this opens it, that closes it. Following command redirect standard in to a file, then read from that file line by line. Let's have a look. This just saves the default behavior of the standard in to a new file descriptor so that you can restore standard in later. Okay, what's happening here is you open a new file descriptor and then copy whatever is in standard in to that new file descriptor. So now this file descriptor 6 point to the current terminal, same as all others in this case. And then this one, what do you think this will do? You've guessed it, it will change standard in to point to a file called foobar. After this, whatever you after this, if you do read command, each read command will read a line from foobar. Okay, so first read command is the first line from foobar. Second read command is the second line from foobar. Okay, and then what this does, just housekeeping. What that does, copies the pointer in the new file descriptor 6 back to standard in. What do you think that will happen? It will copy whatever is pointing in the file descriptor 6 back to standard in. So it will point to the terminal again. And then this one, can you guess what this does? Yes, it closes file descriptor 6, just housekeeping. Okay, let me go through with that. Okay, so we want to save standard in for later, so we can reset standard in. Okay, we copied standard in to file descriptor 6. So file descriptor 6 is open and points to the current terminal. You're not convinced? Let me show you. Can you see here? This is the file descriptor 6. It points to the current terminal. You know that because you see for standard in points to dev pts 0. Same thing for file descriptor 6. So they both point to the current terminal. Okay. Now, what does this do? Let me show you. It will change standard in to point to a file called foobar, right? Oops. Yeah, you have to do this inside. You have to do this inside a script. Let me do it. Okay, so read from foobar. Okay, so we save standard in to reset later by saving it to fd6. Do you get that? And then we set standard in to now point to file foobar. Okay, so that's what happens here. Okay, and then, well, let me see what's inside foobar. We have these 6 lines. Okay, let's see if we can read it line by line using the read command now. Let's read from foobar line by line using read command. So read line 1, save line 1 from foobar to line 1 variable, read line 2, save line 2 from foobar to line 2. And what we're gonna do, we just echo it, maybe. So print lines 1 and 2. Okay, is that it? Yeah, and then the housekeeping stuff. So first, we don't need, well, we need descriptor 6 to reset standard in, right? So let's do that. So we copy 6 back to standard in. So this reset standard in to point to the terminal again, and then close file descriptor 6. Okay, let's see, what do you expect will happen if we run this? It will print lines 1 and 2 from foobar, right? So what do you expect? it will print Abraham Lincoln. Let's do that. Yep, can you see? First two lines has been printed to the terminal. Okay, so let me remind you how this works. The critical line is the second one, this one over here. Okay, what happens is it points standard in to the foobar. Okay, so now we are free to use read command to read from foobar line by line. Okay, so if you do read command the third time, you will read the third line of foobar. Another one is fourth line of foobar, and so on. We can read from the foobar line by line using the read command. Okay, because standard in now points to foobar. Okay, that's why it works. Okay, so notice we saved the reference to the default standard in at the beginning and then restored it at the end. This is a recommended practice to restore the first three first three file descriptors: standard in, standard out, and standard error. Okay, just a good practice, housekeeping. Okay, so what it means is we copy the pointer in standard in to to file descriptor 6, and then we copy it back to standard in. Okay. Okay. Here's a standard out example. First, we copy standard out to file descriptor 6 so we can reset it later, like before. And what will be inside file descriptor 6 will contain the pointer to the current terminal. And this is an important part. This, what does it do? Can you guess what it does? It will do this. It will change the pointer inside standard out to point to the out file instead. So from here onwards, anything you echo to the terminal will be saved to out file. So we've done 3 lines of echo here, so there will be 3 lines inside our file at this point. And then the housekeeping again, we restore standard out. Can you see what happens here? And then we close unneeded file descriptor 6 because we don't need it anymore. And as expected, out file contains these 3 lines. If you're not convinced, let me go through with you. Okay. Let me just write it down then. Okay, so the first exec, what that does, it copies pointer in standard out to file descriptor 6, which is a pointer to the current terminal. Okay. And then we now point send that out to out file. What happens? We point standard out to out file. Okay? And then anything from here will be, or the output to the standard out will be saved to out file instead of the terminal. Okay? If you do jumping kangaroos will be the first line of the out file. Joey taking a ride will be the second line in the out file. Oi 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 will be the third line in the out file. Now housekeeping. This copy back standard out to point to terminal again, and then close file descriptor 6 because we don't need it anymore. Okay? Do you get what's happening? Okay, so what will happen? What do you think will happen? You guessed it, you will copy these 3 lines to where? To out file. Okay? Done. What's in the out file? These 3 lines. Okay? That's cool. Okay. We can also use 2 different file descriptors to redirect both standard in and standard out. Okay, this is a more advanced example. So first we make a copy of standard in so that we can reset it later, and then we point standard in to full bar, and then we copy the standard out for the same purpose, and then point standard out to out file. And this command over here, you need to understand what's going on here. Okay, so what is happening so far? We start with everything pointing to the terminal, and then over here, as you guessed it, it will point standard in to full bar, and it will point standard out to out file, and then it will copy before we do this and this, of course we make a copy, right? We made a copy of standard in, we made a copy of standard out. Okay, okay, and then what does this do? But first let me introduce with tr command what it does. Okay, in this case it will change, well, it will capitalize whatever is inside standard input. Okay, okay, so we know the out file contains this from previous example. Okay, if we pipe it in, can you guess what will happen? It will capitalize everything. That's what it does in the right hand side. What's on the left hand side? In this context, cat here with the minus sign, it means standard input. Okay, and in this case, what's the standard input? Standard input points to foo bar. So what do you think will happen? What would this do? Can you guess? I'll give you 3 seconds. What we'll do is it will feed in the content of foo bar. That's this part. And then it will change every character to uppercase. And then it will save everything to art file. Okay? Let me just check. Alright. What's in foo bar? Okay, that should work. Alright. So, and then the housekeeping duties again. What will this do? It will restore standard out from file descriptor 7, right? So what this will do is we will change it back to point to terminal again. And then this redirection, what do you think that will do? It will close unneeded file descriptor 7. The second one is similar. You can guess what will happen, right? We'll copy back standard in to point to the terminal again, because it's copying pointer in file descriptor 4 into standard in. And file descriptor 4 points to the terminal. And then it will close file descriptor 4 because we don't need it anymore. Okay? So that's that. Let me... Can I do this line by line? Will it work? Let me try. Okay. Let me just see what's in the file descriptor right now. Yeah, it looks normal, right? So we can... So we're copying standard into file descriptor 4 so we can reset standard in later. And then we point standard into foo bar. Oh, no, you have to put it in a script again. Let me just do that. Okay. Let me do standard out and standard error redirection. Okay, so we copy standard in pointer in standard into file descriptor 4, which is just pointing to the current terminal, right? So we save standard in for later reset, and then we redirect standard in to point to file foo bar. Can you guess what this will do? We'll save standard out for later reset. What do you think this will do? We redirect standard out to point to our file. So this is a very it's a little tricky to understand because it's a combination of whatever we learned before. Okay, so what will this do? This part, it will feed in lines from, can you guess, full bar. Okay, and this part capitalize every line, and then the output of the command is saved to, can you guess, out file. Okay, then housekeeping, this means restore standard out to point to the current terminal, close file descriptor 7, and guess what this will do, right? Restore standard in, close file descriptor 4. Okay, so let me go through it because it's a bit difficult. So here, this line over here, it changes the pointer in standard in, right? Let me reset it. So this signifies file screws 4 and 7 have been opened for housekeeping purposes, and then we point standard in to full bar, we point standard out to out file. So what this command will do, it will get lines from full bar and then save, and then capitalize everything that are fed in from full bar, and then save everything to out file. Okay, let me check. Yeah, I think it should work. So what do you think will happen? We get content from full bar, and then we will capitalize it, and then we'll save this to where? You guessed it, to out file. Okay, so let's do that. We are checking out content of our file. Can you see? It's the same. Hope you understood that. So we get this. Okay. Redirection is a clever way of avoiding the subshell problem. That's what I mentioned earlier. Now we will introduce what it means. Okay? Pay close attention to this. Maybe we want to count the lines from output file. So how many here? 6 lines, right? So maybe we want to get lines to equal 6 after this while loop. But if you echo the lines here, it's still 0. Okay? That's because this portion over here created a subshell so that whatever changes inside will not be visible to the outside of that subshell. Because of that, this incrementing lines has no effect. This results in this to be still 0. Not convinced? I'll show you. Let me just copy and paste. So okay, so I'll go through it again. The intent, if it works, is to count the lines inside out file. We mentioned that it should be 6 because there are 6 lines in out file. But because cat out file pipe, this portion has created a subshell. This incrementing line is not visible outside of the subshell. So when you access lines outside of the subshell, the value stays as 0, not 6. Okay? Show you. Oops. Yeah, the value of line is still 0. So that is what subshell problem is. Okay? How do we fix it? We fix it using redirection. Okay, so we open our file descriptor 3 and point it to out file prior to the while loop. And you can see over here, this is another syntax for redirecting file to the while loop. And if you, this is just housekeeping as usual. Now if you get the lines, it will hopefully say 6. Okay, so let's do that. Okay, let's copy and paste this. And then run it. See, can you see total number of lines is 6 because alpha has 6 lines. Okay, let me just check something. I mentioned, oops, I mentioned this is a different syntax of redirecting the file to the while loop. Will it still work if I do this instead? Okay, let's try that. Yep, still works. That's good. Okay, the last section. Well, this is just what we covered immediately before this. You can pass this redirection. Feed in file names content as input string to a code block, line by line. Okay. What I mean by code block, it can be a while loop, until loop, for loops. And here's an example. You can just simply do this redirection So the left hand side is the whole while loop, and the redirection applies. So do you remember the precedence or the order of execution? Do you think we will run the while loop first, or do you think we will do this redirection first? Can you remember? Yes. Firstly, we set up the redirection, so we set the redirection first, and then we execute what's in the left hand side. Okay. So oops, sorry. So it's like this is the code block, and then we do redirection, such as like this. So we do redirection first, and then execute the code block. This is like command redirection, or something like, I don't know, ls x y z some file or something like that. So this is like we got a code and then a redirection, right? So we do the redirection first, and then we execute the code. Okay, that's the order. Okay, we can do the same thing, but with a different syntax. For this, the last example, we copy standard in for later reset, and then we point standard in to out file. If you do this, then you don't need this redirection over here, because the read command inside the while loop gets executed once per iteration, right? And each iteration it reads the current line of out file. So the first time, the first iteration, read line will read the first line from the out file. On the second iteration, it will read the second line from out file. In the third iteration, it will read third line from out file, and on each iteration, the line string is saved to line variable, so you can do whatever you want in the middle. And these are just housekeeping. We've seen them many times. So do you see the difference? The first example, we redirected directly using a this redirection that points standard in that is affected to this code block to point to the out file. The second example, we simply just redirect the standard into the out file, and because the while loop here uses read command, it reads line by line from standard in, which points to out file. So both of them works, okay? But I think the second one is cooler. It's more cool, okay? Because it just works, right? Okay, I did my best to elaborate on details of this document. I'll probably expand on this document in the near future and add more materials in. I will link this document in the description so you can follow it along. Thank Thank you so much. See you next time.